There are a few types of lessons that you'll encounter while using LearnCo. Lessons like this one are considered READMEs. Note that on LearnCo, you can easily tell that a lesson is a README because on the right side you will only see the I'm Done button that you must click before continuing to the next lesson. If you are using the in-browser Learn IDE, there will also be a button at the top of the lesson that says Sandbox. Clicking this button will open up a blank workspace where you can create files, write code, and test concepts. The other two types of lessons that you'll see are code-alongs and labs. These lessons will ask you to practice what you've been learning by writing some code. Code-alongs typically ask you to code while following detailed instructions, guiding you through the process, while labs are test-driven. You must work out the problem and deliver a solution that passes the tests in order to complete the lesson. If you are working on either a code-along or a lab, you will see that instead of a sandbox button, an Open IDE button will be present. Clicking this button will take the lesson you're reading, create a personal copy for you, which we call a fork, and then download the content to your local environment, which we refer to as cloning. This process is automated to make it convenient for students to get started on a lesson. In this video, however, we will be walking through these steps manually on GitHub, as it is helpful to understand what is happening behind the scenes. Forking and cloning from GitHub are essential parts of version control. So if you eventually decide to move away from the in-browser IDE and use a different development environment, such as Atom or VS Code, the steps we discussed here will be applicable. Just beside the Open IDE button is a button that looks like a small figure with animal ears, waving. That's Octocat, GitHub's mascot. Clicking this button will open the remote repository for the lesson you're currently on. In this example, you can see here that this repository is owned by the LearnCo students organization on GitHub. To fork a repository, simply click the Fork button on the GitHub interface, choose your own personal account, and GitHub will automatically create a copy of that repository under your account. As you can see, this repository is now owned by the Maxwell Benton user, and it has been forked from the LearnCo students account. Once you've forked a repository to your account, the next step would be to clone the repo. Cloning is the process of downloading a repository on GitHub to your computer so that you can make changes to the same repo. So just to be clear, forking creates a separate duplicate repository, but cloning will make a linked copy of the same repository. This way, you can do work on your own computer, but any changes you make can be saved to the remote GitHub repository you cloned down from. GitHub provides us with a clone URL right here. Notice that you can choose between two clone URLs, the HTTPS and SSH versions. Either option will work in our case, but GitHub currently recommends using the HTTPS URL as it will work everywhere, even if you are behind a firewall or proxy. Right beside the URL, click the Copy button to copy this URL to the clipboard. Now we're going to go over to our terminal and interact with the Git command line in order to clone this repository down to our computer. First, I want to go into a directory where I keep all the repositories I've worked on. So, I'm going to cd into my development directory and then into a subdirectory, labs. Now that I'm in my labs folder, if I use the command git clone, then paste the clone URL I copied from GitHub, a new folder will be created inside the current folder. This folder will be named after the repository I cloned from. If I list all files and folders in my current directory, we can see it here. Now that we've cloned down a repository from GitHub, let's cd into the directory that Git created and take a look at what this repository looks like. This directory is linked to the remote repository I cloned from, and I can confirm this by typing git remote-v. This means that this directory can interact with GitHub. Git is keeping track of every single change I make to the code in this repository. I can ask it to show what all the current changes are by typing git status. Currently, Git is telling me your branch is up to date, meaning that there are no new changes. This makes sense because we haven't actually changed anything yet. Let's create a file using the command line. We can do this by typing touch, followed by the file name and its extension, like so. Now, if we run git status, we will see that this file has appeared as untracked. Git status will always summarize the current differences between your recent changes and the last commit made to this repository. Now that we've made a change to our repository by adding a file, we need to learn how to tell Git to keep track of it. We do that via the git add command. Using git add, we specify the changes you want to keep track of by typing the file name after git add and pressing enter. Now, if we type git status, we will see that this file no longer shows up as untracked. Git is aware that this file is a new addition to our repository. Git add is used anytime we want to make a change to any of the files in our repository, old and new. A good shortcut to remember is that instead of having to list out each specific file we changed, we can instead type git add dot. This will tell Git to track all the changes made in the current directory. If I had made a bunch of files, using git add dot will track all of them using one command. You will sometimes hear people refer to this step as staging files. We are telling Git to get all these files tracked and ready. Ready for what exactly? Ready to commit. Committing your work is like creating a new save point. When working on a project using Git, it is possible to switch back to any previous existing commit. For instance, maybe in some recent changes to a project, you've accidentally broken everything and can't figure out what went wrong. Well, if you have a thorough commit history, it is possible for you to step back in time to an earlier version of your project and begin from there without losing too much work. We can create a commit by typing the command git commit followed by -m, then a message, in quotes, related to our commit. Now, if we use the git status command again, we'll see that our branch is up to date again. If we add another new file or make any changes, we will need to use the git add and git commit commands once again for those new changes to be added to the commit history. Now that we know how to make changes locally, track them, and create commits of our work, we can get the work we've done on our local computer and push it up to the remote repository on GitHub that we originally cloned down from. If we use the command git status again, we can see that it states your branch is ahead of origin master by 2 commits. In this example, origin master is the repository that we cloned our work from. If we look at the repository on GitHub, we can see that this lab is at an older commit, not one of the commits we just created. If we use the command git log, we can see here is the commit that GitHub is aware of, and here are the 2 more recent commits that we've created. In order for our GitHub repository to be synced up with the local work we've done, all we need to do is use the git push command. Git push is going to take all of my local commits and update the remote repository with them. We can see that this worked here. Git has taken my local master and copied it to my remote master on GitHub. If I go back to the lab on GitHub, I will see that the commits I created locally now appear on the remote repository. In your terminal, you can type git push whenever you want. If there are no new commits found, though, nothing will happen. That is the essential workflow for Git version control. Again, if you are currently using the in-browser Learn IDE, you may not encounter these commands while working through lessons, as they are automatic. However, anytime you begin working on personal projects or in collaboration with others, it will be important that you understand the difference between remote and local repositories and the steps for proper version control.